right, welcome back to another episode of PTR Perspective, again from CWIEME Berlin. My next guest is David Hind. He's the principal engineer at Drive Systems Design. Welcome to the podcast. Okay. David, please start by a quick introduction of yourself, the role that you're playing at Drive Systems Design.
Hey, my name's David Hind. I'm a principal engineer at Drive System Design, and I work in what's called the electrified powertrain team. So within that team at Drive System Design, we focus on the design and development of motors, power electronics, and controls, specifically motor controls. Within the wider business, that fits into the other functions, which are mechanical, so transmission design, housings, casings, etc. Development and test. So we've got our own in-house test facilities, which we can actually test the things we develop in-house, and then controls, which is more sort of the vehicle level transmission controls. So I think that's a little bit about Drive System Design. Me personally, I started off as a motor control engineer, so I did a PhD in something called sensorless control AC machines, and then over time slowly shifted more towards the power electronics side, but very much keeping my hand on the application side of things, which obviously as well covers the motors when you're doing motor control. So a little bit of a feat in several camps, but I think that keeps things interesting for me. So
All right, perfect. We have the right person to address some of these topics that, I'm pretty sure our audience really wants better insights on these topics. So on electrification and, having these systems in place, for example, conversion systems, AC-DC conversion, DC-AC conversion, I've seen this gradually. This is becoming the core part of the change that we see in mobility and electrification. What role do you think that is playing in reshaping our industry?
I think there's a few things going on at the moment. I think firstly, at the kind of the very top level of vehicles, if you like, for automotive, but not necessarily automotive, like across a range of sectors. So, the propulsion system, choosing the right propulsion system is key. And I think at the moment it's a little bit of not quite sure which way things are going. I think we all recognize that in the longer term, things are going to go battery electric. But in the shorter term, there's probably a journey that's a little bit longer than we thought in terms of some of the other technologies that are still competing. I think that's at a high level. And then I think at the lower levels, we're seeing a real shift in the technology that's being used as well, because, there's several players now, I think, in the market, which are, looking promising, I think, for having a dominant role in the future. But that's at the same time is making it difficult for people on the manufacturing side, say, for example, and people who are taking strategic decisions about directions to really put themselves behind something and invest in it. There's several ways that things could go at the moment. But certainly technology development wise, there's a lot going on. It's a great time to be a powertrain engineer. It's really quite exciting, whether it's motors or power electronics or, a combination of both. There's a lot going on.
And David, I stalked you on LinkedIn, so I've seen your work in smarter control systems and in automotive software. How do you think these technologies are evolving over time?
Yeah. So, I mean, at the moment, I spoke a little bit about some of the motors that are coming through there. Motor controls and the software has got a big part to play in that. So if we look at the shift away from, potentially shift away from rare earth magnets in motors, controls has got a big hand in that to play as well. So whether it's externally excited synchronous motors, which need their own driver from the outside, or whether it's sort of rare earth free magnets that, there's quite a few things you can do on a control there that make them much more interested than they might first appear on paper. And we're actively involved in looking at those as a company at the moment. And then beyond that, at a wider level on the vehicle, I think there's growing scope for AI to be involved. And we're seeing people like Tesla have, they sell the car, but you've got to unlock features within that car. So I think right from the top level, right down to the sort of a low level on the EDU side, software has got a key role to play in the future.
Absolutely. And you mentioned AI, David. I was speaking about this topic, AI's role in power grid, just a couple of hours earlier on the center stage. And one of the challenges that we heard in our interviews with the experts was that availability of information, because with AI it's garbage in, garbage out, right? So you see the similar situation in this industry as well?
Yes, I absolutely do. So actually my PhD would use some AI going way back.
All right.
So we had to try to simplify as much as we can. We had to extract the gradient of a current waveform from a very noisy current waveform. And that was all about the data that you train the AI network for. if you give it good data, you could get a good result. But if you give it, as you say, garbage, it'd give you a result, but it'd be completely wrong. And that's one of the problems we face with commercializing that technology. The reliability of it in a safety critical application was questionable at that time. It's got its place. I think there are things that you can do with it, and I think it will keep on increasing in its presence in the market and its popularity. But I think there's a lot of development work to do to get it to maybe where I think it needs to be to dominate, if you like.
If you don't mind, I would like to sort of do a deep dive into this question, David, about the availability of data. Because when I see AI models being trained on vast amount of information from the web, for example, I don't think that applies on industrial applications, right? So you have data that is in silos. In some cases, data, these are processes that are never documented, for example, right? So, like, how do you think that this problem will be resolved? Otherwise, any AI system which is, designed for these industrial applications is not going to have a great outcome if the data availability is a problem.
Yeah. I mean, personally, I think there's got to be a shift in how we collect data, how we share data as well. I think that's going to be key to it. Obviously, there's a competitive element to it. If you're using AI, you want to be using it to create something for yourself that you can then commercialize and sell. And if everybody's sharing the data, then everyone's got access to the same data, so they've got the same ability to generate the same systems. But I think in the interests of technology development and pushing things to the next level, I think that is going to be important to be able to train these networks. It's the same if I think we have a system called something called EPOC that we use at drive system design, and it's an optimization tool for designing drive systems. So it tells you, based on data, what would be the best selection of modes of technology, for example, the power electronics technology. But it all relies on sort of drive cycle use case data to make that decision. And even at that level, it's if you give it poor data, that's where it starts to fall down.
Yeah. And there's no room for error because, with ChatGPT, it's all fun and jokes. You have a hand with 7 fingers, for example. And, just because the data available on the web is not good enough. I don't think we have that kind of, wiggle room for industrial applications. You cannot afford these problems.
So, I mean, the other thing is it's got to be backed up by a lot of verification as well. So, making sure that it does behave in the way it's supposed to behave under all conditions, especially if it's going anywhere near if it's safety critical. I think that will be key. Right.
Tell us about your experience at CWIEME. It's day one, so obviously, it's still start of the show. What value do you think you'll be able to, take from the event, and why is it important? What type of industry players are you looking to meet at the show?
Yeah, so I mean, Drive System Design is a consultancy company, so we rely on our customers. We rely on meter manufacturing partners as well. So when we design systems for people, we can actually manufacture those and design them in a way that either can fit in with existing manufacturing process, or we work with manufacturers to adapt, modify, create those new manufacturing processes. And events like CWIEME are absolutely critical for us from being able to meet those kind of people, get those connections, understand the problems that people are needing to solve, trying to solve, and then start to go away and think about how we can actually solve them together. And I will say CWIEME it's a great show. There's a lot here, so very impressed so far.
Amazing. Looking ahead, David, what emerging technologies or trends that really excite you? Do you think that's really exciting moving forward?
Yeah, I think as I say, there's a lot going on at the moment. Exciting times to be a powertrain engineer. I think there are probably 3 areas that really excite me at the moment. On the motor side, I think there's sort of the search for something alternative to rare earths. That's something that's getting a lot of attention at the moment, and it's kind of new frontier, if you like, again. Old technology that's been known about for quite a long time, but with the sort of new methods and processes and technology coupled together with that, we're able to really kind of explore some new design spaces with that. I think on the power electronics side, there's a couple of things at the moment. So people are starting to give more attention to the wide bandgap, ultra wide bandgap devices. So your gallium nitride is actually starting to get a bit more interesting at the moment. And on silicon carbide, which we've seen as dominant in the past few years, even that's started to see people are looking at different architectures. Within those different architectures, you need different devices that aren't currently available off the shelf, not from many people anyway. So it's real kind of development in that area. And then the last thing is X in one. So more integration, putting more things together, benefited from the systems being integrated into, a single box essentially, being able to cut down on some of the parts in there that you might otherwise have had in older systems where things were all distributed all over the place. So yeah, real exciting times.
Fine. Something that's linked with this question, David, is I see that in other, parts of the industry, especially in the power grid industry, there is a issue of attracting the right talent. It's not an, very attractive sort of field for young engineers to come in. I see the history of power electronics, semiconductor, for example. The other day, I watched a documentary on the invention of the blue LED. Such a fascinating story. How much like brain power went into creating this one invention that has made everything around us possible. It's so inspirational.
Yeah.
But so in the power grid there is a big issue of attracting the right talent, attracting actually young engineers to join the industry. Is it the same for this industry as well, or there is still enough sort of attractive exciting parts that you don't have to go out of the way to sort of attract young engineers?
Yeah, I think it is still a problem. So if I think back to my case and what I see as being some of the problems is uh, education, certainly in the UK, they don't tend to focus so much on engineering. It's sort of your physics, your maths. It's quite far down the line before you really get to see how that kind of fits together and to see these end applications. I think we could do more in terms of pushing that at an earlier stage, and also, kind of focusing more on the application side of things. So, the things that younger generations would think was really cool or see as really cool, kind of allowing that to be filtered down so they can see actually how do you get to work in that industry? What do you need as you go along in terms of education and development to be able to do that? And then I think industry as well has got to play its part. So as well as those outreach opportunities, reaching into education and helping develop people from a young age. I think as well, as people are coming through, finding more opportunities to get people involved in companies, seeing work experience firsthand, getting to be actually involved in that and actually doing something when they're on way of experience as well. I think that's really important. Uh, I think if we could improve that, then I think it will help. But yeah, it's still a challenge at the moment.
All right, fine. I mean, this is an industry that has always been very interesting for me. Power electronics, like I've studied this, like 10 years ago. This used to be like one of the core topics that I always thought that will shape our industry moving forward, and this is the case. Yeah. But thank you so much for joining us, David. It was a pleasure having you. I'm sure that our viewers got a lot of insight from this. And I'll see you in the next episode. Thank you so much. Stay tuned.